It becomes rapidly apparent from this discussion that autonomous operation is very much scrutinised and is likely to be a major factor driving sustainability, both in terms of carbon footprint and also in terms of operator safety. The question of powertrain suitability is addressed, and in doing so, a whole range of factors are discussed. What extent can autonomous operation benefit the industry, not least because of the challenges involved in finding skilled operators? And are all machine and driveline types equally suited to autonomous operation?
I don't think all are suited, but I think some are actually. And then I think, as you say, that to find drivers can be tricky at different markets and so on. And I mean, different types of automation will absolutely support the driver then. I mean, we have solutions like dig assistance and terrain memory and cruise control that is rather low level automation. Then we have a system that is totally autonomous. Then like we have what we call the TARA system, that is small haulers that is running, so to say, without driver in a fleet, you can say them. So different things then. But I think different machine types are a little bit more or less difficult to automate at the end. But then, of course, we also have the 5G and the opportunity 5G gives that they can run teleop, so you can have the driver sitting 100 miles away actually and driving a machine far in the forest or in a dangerous place in a mine or whatever. So it's another opportunity that we're also looking into.
Dietmar, what are your thoughts about this?
Absolutely. This is an area that Trimble is very focused on, I would say. And, two major aspects of sustainability that we believe are important. One is actually safety. So in the long-term future, as we start to see some equipment that might be operatorless, right? You'd end up not having a cab. And from a safety perspective, we see a lot of injuries on site are from actually getting in and out of vehicles. This is sort of inevitable. These are big. They're hard to get in and out of. Everyone's trying to reduce the amount of injury that happens, but that's where a lot of injuries tend to occur. So as you remove that, you'll end up having less injury. But really from a pure carbon standpoint, again, we think there's a tremendous opportunity. We basically did a study this past year as we're working to prove out how productivity and efficiency gains drive sustainability. What we did is we compared recently released product we had for an auto steering compactor, right? So you still have an operator in the vehicle in the compactor, and we compared an experienced operator to an inexperienced operator to the auto steering just driving itself. And what we found was a 15 to 30% efficiency improvement over those operators, and that directly means a 15 to 30% reduction in carbon emissions, largely because using auto steering, you can reduce overlap when you're doing compacting, and especially as you have to use the compactor multiple times over a site, it just starts to get more complicated for an operator to do that as effectively as you can when you have it purely mapped out through an auto steering and autonomous solution. So we see tremendous opportunity through autonomy to drive sustainability overall in the industry.
Jeremy?
Yeah, I think, we today, right, we participate in autonomous applications that are diesel powered, right? I think the question in there was, is one powertrain type better suited than another? Probably, right? I think you can do it on again, things out there today. We are doing it on things out there today. Some of the things mentioned like steer assist and other things. Obviously, as different portions of some of these machines start to electrify, I think it probably gives you a little bit more finite control over some of those operations. Obviously, I think the automation and the connectivity trends kind of go hand in hand. At least from our perspective, the farther removed person is from the cab, right? The more interest we have in making sure that asset's healthy. Thinking operationally, construction-wise, I think some of the dig assist type functionality was mentioned. I think traditionally, if I needed to dig a 2-foot deep or a 3-foot deep trench, I probably am in my excavator. I maybe take a couple scoops of dirt out. I get out of the cab, probably leave it running, go out with my measuring tape and say, nope, I'm 18 inches. I get back in, and I do that 3 or 4 times before I get it right. Through some of the solutions that folks like Trimble and others are bringing, you don't have to get out, right? Which means you're not wasting your operator time. You don't need as skilled of an operator, right? We all know that's a problem, as you mentioned before, but you can get those jobs done a lot quicker. And then even thinking outside of construction for some of that auto steer, agriculture markets, I think a lot of those are starting to show some of these 48 type volt steering systems. If you think out in the Midwest or somewhere where you've got these miles long rows in a field, getting from A to B in a straight line is one amount of plowing or distance. If I've got somebody in there probably on their smartphone, because we're all always on our smartphone, maybe left and right on the steering wheel, I'm not really taking an efficient A to B path. And probably wasting a lot of time, wasting a lot of fuel, and just not being very efficient. So I think there's a lot of opportunity with automation that comes on that's really going to make a big impact. And I think, as Dietmar said earlier, it takes kind of a combination of all the different types of products that the companies on the call here would bring to market.